Hey guys, welcome back to chapter 15. We are going to continue our discussion on the equilibrium constant K. So in the last video, what we did is we did calculations with the equilibrium constant K, and then we determined what those calculations meant for the reaction. What we're going to look at now is we're going to look at modifications to this equilibrium constant K. So this is kind of a tool that we're going to put in our tool belt, and we'll be able to use it later on in this semester. So two modifications that we're going to look at for K. The first is, well, what if we reverse the reaction? So we typically write a reaction, reactants, products. But what if we wanted to flip that over and make the products the reactants the products? What would that do to the value of K? And then the other modification is, well, what if we want to increase each of the reactants and products? So what if we want to multiply through by some number? So double it or triple it, what would that do to K? All right, so first modification. Here we've got our generic formula. So our generic formula is as follows. We've got A reacts with 2 molecules of B to form 3 molecules of C. And here's our K value for that. And it's got the subscript F just to explicitly tell us that this is the forward reaction. So A, B becomes C. What if I was interested in going the other way? So what if I had a bunch of C sitting around and I wanted to see what the equilibrium looks like when it breaks down? Let's look at the reverse reaction. So now C is our reactant and A and 2B are our products. So when I look at the K value here, so this is the K for the reverse reaction, that's why we have the R. Now we still have products over reactants. So A and B are on the top and C is on the bottom. So essentially what we did to get from here to here is K for the reverse reaction is going to be the reciprocal or 1 over the forward reaction, okay? So if we had a value for this, so if we said, well, the Kf for the forward reaction is 42, for example, and I said, okay, well then what's the K value for the reverse reaction? You would take the reciprocal, 1 divided by 42. So the K for the reverse reaction would be 0.024. Okay. So this is important to us as chemists because sometimes we can't always study the reactions that we want to study. Let's say we are interested in A and B reacting to become C. But for whatever reason, we can't do that in our lab, so we have to study C breaking down into A and B. Some reactions we just can't manipulate. So we could study this reaction and then use this concept to determine what the K value would be. Okay, so that might be a place where it's handy. So that's the first modification. If we reverse the reaction, K becomes the reciprocal, 1 over. The next modification that we want to talk about is what if we want to multiply through by some number. So here again is our initial reaction. So A plus 2B produces 3 molecules of C. So let's say we want to multiply by some number. Let's say we want to double everything. So instead of looking at 1 molecule of A, I want to look at 2 molecules. And instead of looking at 2 molecules of B, we now have 4. And instead of producing 3 molecules of C, we now have 6, right? So we just multiplied each of the coefficients by 2. So that N, where do those coefficients go? Well, that N is going to end up in the coefficient place in our equation for K. So when we multiply through by some coefficient, we're going to see that show up in the exponents. Now I can simplify this out. So all of these have the exact same exponent. That exponent is the number n. So I can take that n out and make it look something like this. Well, why is that helpful? So let's say the K value for this reaction again was 42. And now I say, you know what? I'm going to double all of these. I want to look at 2 and 4 and 6. So what would the K value be at that point? So then it would be 42 raised to the second power if we double everything. So now the new K value would be really big. Okay. So again, these modifications are helpful because if we can study just this base reaction and then we want to look at something that looks a little bit different, it's nice to be able to math through that instead of having to try to formulate this scenario in the lab. Okay. So what I want you guys to do now is I want you guys to determine the K value for the following reactions. So all of them are some sort of modification to this original reaction. So nitrogen reacts with oxygen to produce ammonia. And then we just manipulate that reaction 3 different ways. So determine the value for K for letters A, B, and C. I'm going to go ahead and pause the video, and then I'll do it in just a moment. All right. So for this first reaction, what we first need to decide is what was the manipulation? How did it change? So here I see that the coefficient for N was a 1. Now it's a 2. And this was 3. Now it's a 6. This was 2. Now it's a 4. So we must have multiplied this equation by the number 2. Okay. So if we multiplied this equation by the number 2, we're going to take the original value for K, which is 312, and we're going to raise it by whatever we multiplied by. So we're going to raise it to the second power. So the new K would be really, really big. Okay. Let's look at the next one. Ooh, fractions. Gotta love fractions. All right. So the first one, nitrogen had a coefficient of 1. Now it has a coefficient of 1 over 2. So 1 to 1 over 2, we divided it by 2, right? And 3 to 3 over 2, we divided it by 2. And then 2 to a 1, we divided it by 2, okay? So essentially, we multiplied this equation by 1 over 2 or by 0.5, okay? So nothing changes here. We multiplied by a fraction, and that's kind of odd, but we multiplied by a fraction. So we're going to take the K value. We're still going to raise it to the power, but instead of raising it to a whole number, we're going to raise it to 1/2, or we're going to raise it to 0.5, okay? So we take 312 raised to the 1/2 power, and we get 17.7, okay? So a little bit odd, not something that you probably have seen a lot, but still something that certainly can be done. All right, for the last one, we've got a couple different manipulations here. So for the last one, the first thing I see is ammonia is now a reactant. So I reversed this reaction. So that's one manipulation. We reversed it. What else did we do? So we see that ammonia became a reactant. And the coefficient for ammonia also changed. So it was a 2 and now it's a 4. Same thing for nitrogen. It was multiplied by 2. Hydrogen, it was multiplied by 2. So we also multiplied by 2. So when we find the new K value, we reversed it. So reversing it is going to take the reciprocal. So 1 over 312. And we also multiply by 2, so we still need to raise it to the power 2. It doesn't really matter what path you take through this problem. Do you square it first and then take the reciprocal, or reciprocal then square it? The algebra is going to come out the same. Okay. So I'm going to take 1 divided by 312, and then I'm going to square that number. And I get something really little. So 1.05 times 10 to the negative 5th. So 2 manipulations that we can do to K. We can take the reverse. We can multiply through. And if we know the value for K, then we can just simply take the reciprocal, or raise that K value to whatever we did, whatever we multiplied through by. Hope you guys found this helpful.